10 minutes before the demo, but everything worked fine then. No, before the first demo. Sorry, trying to make that clear. We had problems with image acquisition. We were using a different webcam that was going to do 3D modeling, and it would take images from both webcams, which was going to be part of our special task, but unfortunately the frames per second on the webcam were very low, and for the money we spent on it, it didn't really perform to what we needed. So we ended up getting a PSI webcam, which was a third of the price and had 4 times the refresh rate and 2 times the viewing angle, so it was much better. We also had some problems with image processing because we have no sensors on our car. We were doing all of it via webcam. So we have to do multiple sweeps of different regions in front of us and around our car, make sure we weren't hitting any obstacles, and etc. Phil now?
Hi, I'm Phil Rizzapato. So I was the main influence of why we had to change cameras, just because Minoru, which is this little guy right here, he didn't turn out exactly the way we wanted him to. He has got 2 eyes, and on paper he's supposed to be able to get 30 frames per second at a reasonable resolution. In practice, his frame rate was pretty low, on average around 22 frames per second, and the quality of the image was pretty bad. We tweaked around with it a lot, tried to turn off exposures, and tried to set all of the video settings to make it the best quality image, but it just wasn't that good. And having a second eye didn't help too much, and we weren't even able to attempt any 3D processing with his webcams. The Sony PSI was definitely the best choice for replacements. It was very economical. We purchased this for $20, and it gives you 120 frames per second at really good quality. The images come out great, and they're really easy to work with in the process. So that was probably like one of the pivotal changes in our design that helped us a lot to get this demo ready for you guys today.
So I'm going to talk a bit about what's unique to our car and some of the things we tried to do a bit differently, I guess. The biggest one was we tried to go with a simple approach and just use the webcam instead of having multiple sensors. We just wanted the one input and try to do everything with that. We figured since it's actually seeing what's on the track, it should be enough. The biggest problem with this was actually finding obstacles in the curves. As the previous group mentioned as well, it's really hard to see the outside of the curve when you're going around it. So the car is pointed towards the outside of the curve. So that was one of the bigger issues we had. Most of the time we were able to still pick the obstacles, but like I said, it made it a lot more difficult. However, we figured that with fewer sensors and fewer components of the system overall, it would be more robust and simpler and have fewer points of failure. So that's kind of the approach we went with. The other thing we did was we had an application on Phil's phone actually was controlling it. That's what we were using to control it outside. So it had rudimentary inputs such as like speeding up, slowing down, changing lanes, things like that, and stopping the program if something happens. And that was done all over Bluetooth. Another one of the features we tried to do was get around the track fast. So I think the fastest we ever did was around 10 seconds on the inside lane. So we were pretty happy with that, especially considering how much we've improved over the course of the project, I guess, with getting the car to speed up. And finally, one of the bigger other things we were trying to do was get it all on an embedded system. So that's, sorry, Dave mentioned earlier that we were trying to do it on a beagle board, which ended up breaking on twice. So our car, the way you saw it, had the netbook strapped on top, but actually everything that it needed to run was inside the car. That netbook was strapped on a couple days ago just to get it to work with the beagle board failing. So we actually were able to fit everything inside the chassis of the car. So that was another one of our bigger features that we tried to go for. And finally, we had a pretty low-cost design. I think that's good. Questions?
said the obstacle avoidance was semi-autonomous, and just what was actually happening? You say you turn left and then it handles the left?
So yeah, so it was just make a lane change to the left, make a lane change to the right, input signal. Yeah.
So does your car actually detect the obstacles, or are you telling it to go around the obstacles so it doesn't actually think there are obstacles there?
So we do have all the code to detect obstacles, and we have all the code to logically handle which lanes to turn in and whatnot. The problem is it wasn't completely reliable, and sometimes it would detect obstacles twice when it was still trying to change lanes. We were trying to tweak it to make it work, but we just couldn't get it ready for this demo. So what you saw was a semi-autonomous lane following. So, and obstacle avoidance. So I was given it the commands to change lanes, but it was doing all the lane changes by itself, and it was following the lanes by itself.
But it didn't see the obstacles.
It did see the obstacles, but that feedback wasn't being used to make decisions.
So no.
Sure, okay. Any other questions? Yes?
In terms of the structure of how you put all the pieces together, did you implement everything independently and then sew it together at the end, or did you develop everything in time to each step?
The main thing we tried to get done was lane following, because like really you need lane following to get everything else going. But lane following wasn't always working, so we were working in parallel to get the rest of our stuff working.
We very much did try to sew it together at the end, and I guess that was the pitfall that we ran into because bringing so many different systems together that may work independently very well, when combined, like Phil mentioned, bringing together all that logic can be very difficult, and we tried to do it in, I think, too short of a time span. That's probably.
If we had another day to not sleep and work on this, it'd probably be working a little bit better. So, why do we not sleep so much?
Yes?
On that note, how much time did you leave for that final product validation relative to the overall development for these guys?
We have been working quite hard recently to get this done, but things just weren't coming together as fast as we anticipated and would have liked.
Yeah, we've had a lot of hardware issues that really just set us back. And when we were the first time we tried to navigate our code over, that set us back probably a week. And then once we got things started working on to the Beagle board finally, and the Beagle board broke, and we had to navigate back again. It took us back another time. I think we spent like the last 48 hours straight working on things, and we were pretty confident that we were going to get it done. And we have the components, but there was just some ghosts in there. We haven't got it all lined out yet.
Thank you very much.